Our V8 engine is moving along, but its firing order will complicate the valve train. Today we'll correct the piston sequence, confirm it with a motion study, and model a parametric camshaft with 8 precisely positioned lobes. Welcome to the Learn It channel. Let's correct the firing order and create our camshaft. So the first thing we're going to do with this tutorial is fix something. Let me show you what we need to fix. Let's just hide the engine block, and you can see that the firing order of our pistons, well, it's good, but we're going to change it a little bit. We're going to make our lives a little bit easier in the future. So we can just go to the motion study, right click the motion study. I'm going to bring down speed, go to infinite loop, and then press play. So this is our current firing order, and again, there's nothing wrong with that, but it's going to make our life a little bit harder in the future. The second reason why we're going to change it is I would actually like to make it so that it's the same firing order, from what I can research, as a Corvette. So let's do this together. I can show you how easy it is, especially because we have designed this entire assembly very well, and it should be very easy to make this fix. And you'll learn some things along the way too. So let's just go cancel. We can go minimize motion study, and then we're going to go right into crankshaft assembly. So I'm going to activate that by toggling that radio button, right click, and go isolate. So this is one thing that's imperative for new users of Fusion to understand, is when we activate an individual component or subassembly, you can see all of the tools within this subassembly that are currently being used to create what we see on the screen. All of these tools are in amongst the timeline for our entire project, but it doesn't necessarily mean that they'll all be in order. For example, the last few tools in the crankshaft assembly are joints, and so they might be somewhere completely different in our timeline. We can utilize that in order to make good decisions, in order to keep our project nice and tidy. But let's go back to crankshaft assembly. I'm going to activate it, right click. I can go unisolate and back to isolate just to make sure that the crankshaft assembly is the only thing that I see on the screen. Now what we'd like to change is this. We'd like this journal and this journal to be in the same position. So they're going to be pointing down or 90 degrees clockwise from 0. And these two journals are going to be facing up or 90 degrees counterclockwise from 0. So this should be very easy to do. What we have to do is, first of all, expand our folder, go to our crankshaft, and I'll show you here, if we click the radio button to activate it, now we have all the tools that we've used to create the crankshaft. Here I'm going to do the same thing. I'm going to right click and go isolate, so all we see is the crankshaft. Now if I expand the crankshaft component and sketches, you can see this is the benefit of naming all of our sketches, because we've got the pin sketch, which is right here, the main journal sketch, and then the counterbalance relief. None of those change. What does change are our joints, our rigid joints. So the first rigid joint corresponds to this. Now because we've used joints, this is very easy to change. If we just use the move tool, well, it wouldn't be so easy to change, and we might make some mistakes along the way. But all I'm going to do is grab this rotation wheel and bring it up to 180 degrees. Let's go OK. And then what I'm going to do is we're actually going to go back in time. And I'll show you what's happening here is, as soon as I adjust one joint, it will actually go and reprocess every single tool for our entire project. But if I bring this timeline marker back to this point in our timeline, and then go back to our top level assembly, you can see that it will stop right there, and everything after it won't recalculate until we're ready to recalculate it. So this just saves a lot of processing power. Let's go back to our crankshaft, and I'm going to activate that. Let's go to the next joint. I'm going to do the same thing here. I'm going to bring this all the way, and we're just going to set this right to 0 degrees and go OK. And then our last joint, we're going to grab that, and I'm going to rotate this all the way to 180 degrees. So each joint is based off of its current location. So 180 degrees, well, the first one was actually based on 0 degrees, and then this is 180 degrees from that. The next one was set to 0 degrees because those were jointed in the same location. and then the last one is at 180 degrees. Once we go OK, you can see that the rest of our timeline still needs to be finished. So in actuality, I'm just going to go up to the top level assembly. I am going to unisolate all. And at this point, because we have designed our entire project very well, nothing should break. Let's hope for the best and go all the way to the end. And just like that, we have no errors, we have no alerts, we have no alarms, and our entire assembly is not broken. So here we go. Let's go back to our motion study and see our new firing order. Again, bring our speed all the way down, go to infinite loop, and then press play. So there we have it. The firing order is set to a Corvette. And if I'm wrong with that, please let us know in the comment section below. If you know anything about firing order of engines, well, we'd love to hear from you too. I'm just going to go pause and go OK. And now we can move on. So I'm just going to go revert position, go back to the home position there, and we can make our engine block visible again. So now we're going to move on to the next component of our engine, and that's going to be the camshaft. So if you're looking for the drawings, please make sure to head on over to the link in the description below. For our paid Patreon members, you can find the document package, which you can download yourself, and we're going to update it with each corresponding tutorial, but you can follow along that way. But just before we get to the actual design of the camshaft, I just wanted to mention that I know that many of you out there have been waiting patiently for the next tutorial in this series. A little while ago on Patreon, I actually released a sample of the engine all the way up to the exhaust from what I remember. But what I wanted to do is include the motion study for all of the rocker arm assemblies, the valves, everything to see if one's computers could actually generate that motion study. Well, everyone came back and said, no, after a few frames, the motion study failed. So I had to do a ton of research. After that research, I found one huge thing within Fusion that's imperative, and I hope to share this knowledge with all of you so that all of you can benefit. I apologize for the delay in getting this out to everyone, but I wanted to make sure that this engine will actually run and will be fun to see a motion study at the end of all the components working together. Now, I still don't know if that's going to be the case. However, after doing all of the research that I've done, I made one huge mistake in the original practice design that I've been working on behind the scenes. And that was, if I expand the cylinder head assembly, you can see that we have the camshaft bushing assembly, the retainer assembly. These are static components. In other words, they do not move. Once they're installed, they stay there permanently. And when it comes to parts that do not move, we can create sub-assemblies within a sub-assembly with underneath the umbrella of our top level assembly without any problem. But as soon as it comes to moving components, components that revolve or move in some other way, and we end up creating a link between those moving components and moving components within another sub-assembly, well, Fusion doesn't like that very much, and it won't work as smoothly as possible. So that took some time to figure out. I hope to share that with all of you, that this is a huge thing within Fusion in order to make our assemblies work. Now, I hope that this works a lot more smoothly. There's some other tricks that hopefully we can implement along the way to make this as smooth as possible. But I'd love to hear your suggestions, everyone, if you come up with better solutions, if you know how to make motion work a lot better when it comes to assemblies that have a ton of components, a ton of moving parts within them. Well, we'd love to hear from you. So please let us know in the comments section below any tips and tricks that you might have as well. But at this point, what we're going to do is we're going to create under the umbrella of our cylinder head assembly. I'm going to activate that, and we are going to create all of the components that move within this assembly and not create any further sub-assemblies. So I'm going to create the camshaft and then all of the individual components for the rocker arms, not as their individual assemblies, but as individual components under this assembly. So the first thing we're going to do is create the camshaft. So let's go right click and go to new component. We're going to call this the camshaft. Next, I don't want to see all the rest of the geometry and other components in the background, so I'm going to right click camshaft and go isolate. Next, we're going to create a sketch. And you can see if I go to the front face that the orientation of our origin is not as expected. If we turn on the cylinder head, you can see that this is indeed the center or the origin of the cylinder head itself. So this is fine. We'd like to create a sketch on this origin because it will help to align everything. Remember that Fusion is based all on different relationships. So if we change the angle of our engine head to something other than it is, and we've created the camshaft based off of this origin, well, that camshaft will automatically adjust to the proper angle so that we don't have to go and update every little single feature when we make tiny edits in our design. So this is great. I'm going to create it on this plane right now, and then everything orients on our screen so that north is the y-axis, and this is exactly what we want. So I don't want to see the cylinder head at this point. I can hide that, and we're going to go to creating our camshaft at this point. So looking at the drawings, we have a ton of different things. We have 8 different lobes. Those are for 8 different rocker arm assemblies. And then we have a bunch of different patterns here, but all the lobes are designed exactly the same. So whenever we look at a drawing, if we can find patterns, we can repeat those patterns to save us a lot of work of having to draft or having to sketch every single element of it. Using patterns will help us to save a lot of time in that process. So what this means is that if we create all of our patterns based off of that initial lobe, if we ever want to change that initial lobe, all we need to do is change the one sketch, and then all the other lobes will update correspondingly. So at this point, let's just create the lobe. I'm going to go to center diameter circle. Here we see that the shortcut is C. So we're going to get into good habits here and use all of the different shortcuts. I'm going to repeat this throughout this entire course, all of the different shortcuts. Sometimes when I get going, I just pick the tool in the toolbar, but let's get into good habits and pick the shortcuts. If you need help with this, we just released a CAD starter mat specifically designed for Autodesk Fusion. It has all the essential shortcuts. It has a ton of different tips and tricks, workflow tips. It's got sketch colors, what they mean. It's got how to navigate, all sorts of goodies. Please check it out. It's a fantastic price, and it will help you to improve your habits within Fusion. So let's press C for circle and start here right at the origin. If we look at our drawing, we can see that this is actually a radius value. So I think I've mentioned this before, but I'll mention it again, that when we're working with full circles, we specify it as a diameter. This is generally the case. And if they're semicircles, we use a radius value. So I'm just going to click, don't worry about inputting a dimension right now, D for dimension, click on our circle, and now you can see it's in diameter mode, or it's specifying a diameter. We don't want that. I want to press right click and go to radius. So here our radius value is 0.15. Let's zoom on in. Let's press C for circle and create another circle up above. Again, I won't specify a diameter value for that. But what I do want to do is go to horizontal vertical and make sure that these two circles are perfectly vertical to each other. So press escape to get rid of background tasks. Now I can move this up and down, no problem, but I can't move it left and right. So let's specify the radius value now, D for dimension, grab our circle, right click radius, and this is going to be 0.075. And then our center point to center point is going to be 0.125 according to our drawing. So this is great. Let's go to finish sketch. And we're not quite there yet. We forgot the tangent line. So let's go back to our camshaft. Let's go to our sketches and double click the symbol there for sketch. And we have to add our lines. So what do you think is the shortcut key for a line? Well, if you guessed L, you would be correct. So let's press L. Now here, I'm just going to grab one of the circles and grab the next one. And here we're going to go to our tangent constraint, select the line, select the circle, select the line, select the circle. So now all of a sudden we have a perfect tangency between this line and the two circles that we've defined. If you're ever wondering what a symbol means on the screen, just single click it, and in the bottom right you can see that it is a tangent constraint. Alternatively, we can press L for line, we can click on our circle, and then as I move the line into place, you can see that it actually specifies or selects a tangent constraint for me. So I'm going to click right there as soon as I see that tangent constraint. The other side isn't constrained, but I can just go tangent, select the line in the circle, and now we have 4 tangency constraints right there, which help to make everything tangent for our camshaft. So this is great. Let's go to Finish Sketch. Okay, just before we get to the next step, I'd like to send out a huge shout out to our sponsor, PCBWay. They've got incredible services. I'd just like to highlight one of them today. Let's go on over to PCB Design. Here you can see you can create professional electronic designs for your next project. This is amazing. You can upload your design here. You can get quotes. You can get help from professional engineering teams, end-to-end development, fast turnaround, manufacturing advantage. And note some of the turnkey electronic design services. You have PCB layout, PCB design, and mechanical and enclosure design. Some pretty amazing things over at PCBWay. Please check them out. I've been working with them for 1.5 years now and have really enjoyed it so far. Thank you, PCBWay, for your support. Hope you guys check them out. Now what we're going to do is extrude. We could have gone in our sketch, and if this ever happens, if you click on the sketch and our model is nowhere in sight, just go to Fit, and it brings it into view. We could go to Trim right now and trim all this away. That's fine. There's nothing wrong with doing that. It might take some extra time. Generally, what I like to do is if there's not too many close profiles, I like to keep them on our sketch because it's very easy to select them and it helps to prevent our sketch from breaking. So I'm going to do that. I'm just going to go undo and not have any trimmed features right here. Just going to keep them whole, but you can do whatever you want. You can trim them. You can keep them. If there are 100 different close profiles, generally I like to trim them so that I just have to select one close profile instead of 100 all the time. It just helps our model to be a little bit more bulletproof when it comes to edits and comes to extrudes. So here we go. Let's go Finish Sketch. Let's now extrude this. What is the shortcut for extrude? If you guessed E, you would be correct. So let's pick all these different closed profiles. If you trim them, you'd only have to select one. Looking at our drawing, this is 0.1 inches for our extrude. Make sure that we have just created a body. So under our extrude, the operation should just say new body. Let's go OK. Next, what we're going to do is I'm going to create a sketch. We're going to create it right here on this face. Again, our body has disappeared. Let's go to Fit. It will bring it into view. Let's create center diameter circle, and this is going to be 0.25 diameter. Again, because this is a full circle, we can go Finish Sketch. And here we're going to bring this on over to the correct value. So this is supposed to go 0.7 all the way to the next lobe. So we're going to go 0.7 divided by 2. So 0.7 divided by 2. Excellent. And then we're going to create another sketch on the other side. Go to Fit. C for circle. Do the exact same thing here. 0.25. And we're going to extrude this as well. Now, to mitigate how many edits we have to do in the future, if we ever need to make them, I want to make sure that this dimension is always the same as the other. So we have a couple different methods to do this. I think the easiest way to do this is actually deleting this circle entirely and pressing P for project. On the opposite side, I'm just going to grab the circle and you can see it projects it using this purple circle on this face. So whatever we turn this dimension into will automatically update on the other side. That just saves us from having to create all these different dimensions and then having to edit them again whenever we need to make an edit in the future. So let's go Finish Sketch, and we're going to extrude this on over to 0.975 divided by 2. From this, we can use patterns to finish the rest of our camshaft. This again will make life very easy when we ever need to adjust something in the future. So what I'd like to do is go to Body, I'm going to copy, I'm going to paste it, and I'm going to go OK, and we can actually paste 2 more bodies. Very good. Now I'd like to turn these 3 bodies into components. So Shift select all of them, and then go create components from bodies. At this point, we have component 27, component 28, and component 29. 27 is currently grounded, so I'm going to unground it. And now select 27, and I'm going to move it off to the side. We can actually grab 28, move it on down here, 29, and here I've actually made a mistake. Sorry, everyone. Let's just go undo, 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 bring it back to the bodies, and we're only going to do one body at a time here. So body 2 to start, we're going to right click that and go create components from bodies. So sorry about that. Let's just go back in time, and I'm going to move component 21 is anchored, so I'm going to unground that from parent, revert position. 27 now is something that we can join to the other body. So this is looking great. What we'd like to do is go to J for joints. So let's go J for joint, select this position and this position, and now we can orient this into place. So let's just move this on over. This is supposed to be 105 degrees according to our drawing. And we can verify a couple things here. Is the distance from this face to the end is 0.35. And you can see we've actually made one more mistake. So I'm going to delete that joint, go back to 27, move this on over, and I actually have to join this face with that face. So we verify everything. I'm going to move this clockwise to 105 degrees, and we can verify these dimensions now. Let's go OK. Pick this face and the other face. You can see the distance is 0.488. It's actually just rounding up to 3 decimal places, but we should have 0.4875. And then the distance between this face and this face on our drawing is 0.7. So this is great. Now we can take this basically assembly and we can start patterning it as well. But what we're going to do first is we're going to combine it. So our target body is the original body. The tool body is over here. Let's just go join and go OK. At this point now it becomes one body that's still in our timeline. Very good. I'm going to right click component 27 and remove it. There we go. So now the joint disappears from there. This is one body we're working with, and we can use this to continue the pattern down the line. So let's go to body now and let's go copy. And this is originally what I was trying to do, is I'm going to paste it. Let's go OK. Let's paste it again. OK, and one more time, paste. We're going to have 4 sets total. Body 3, 4, 5, we're going to select those 3 and create components from bodies. Perfect. Make sure that component 28 is not grounded. We're going to unground that, and we're just going to start with one at a time. So 28, although all of them are laying on top of each other, if you click the component in your timeline, you can just move this off to the side. 29, it will move off to the side, and 30, move it off to the side. So this is looking great. Now we can start joining this all together. So let's go J for joint. I'm going to move on over here, grab that face and that face, and here we have to orient it properly. So what we're going to do is just rotate this 180 degrees. And this, again, with adjusting the firing order of our engine, this is going to be a whole lot easier to work with in the future. So 180 degrees, that's perfect. J for joint, grab this face and that face. This can remain at 0 degrees. So right now it's set to 180. I'm just going to set it to 0 so that both of those lobes are facing down. The front lobe here is facing up. So this is looking great. And then our last one, we're going to select the face, select that face. So this is going to be oriented 180 degrees. So when we look carefully at this, we have this lobe, lobe 8 and lobe 2 are exactly the same orientation. Lobe 1 and lobe 7 are also the same orientation. Lobe 3 and lobe 5 are the same, and lobe 4 and lobe 6 are the same as specified on our drawing. But right now we still have a subassembly camshaft. We only want one body in here. So we're going to go back to combine. We're going to revert position. That's fine. Target body is going to be the original. Tool bodies are going to be the rest. Let's go OK. Now we've got one body under component 28. There's no more body left there. There's just an origin. So I'm going to take all 3 of those components and I'm going to remove them. Make sure to remove, not delete. And now we have one finished camshaft. So let's go to revert position. Let's just minimize our folders here. Go to cylinder head assembly. We're going to make that active. Isolate it. And now what we can do is take this camshaft and we can place it where we need to place it. Now, we're not going to worry about timing too much at this point. We're going to get to that point in a future tutorial where we're going to do a ton of motion. So hope you will stick with us. But what we're going to do is go to J for joints. And what we can do is this little section right here, we'd like it to be centered to this bushing. So here's the good thing with Fusion is with each individual section, there is a midpoint. So I'm going to grab that midpoint and I'm going to do the same thing over here. I'm going to grab one portion of this bushing, and here it's very hard to select that midpoint. So I'm just going to hover over the face, hold down Command on a Mac, Control on Windows, and select that midpoint right there. This should place it perfectly into place. And then I'm going to add some motion to it. It's supposed to be revolute because this is going to be rotating. In real life, it's actually going to be connected to the camshaft via a bunch of gears and chains and things like that. We're going to add motion to this, but for now, we're just going to specify it right there. The rocker arm assemblies are coming up next. Again, we're going to put them all under the cylinder head assembly, but we're going to see some really neat motion coming up soon. So if you've learned something, please hit that like button. If you have questions, we've got answers. Head on over to our Discord server. If you love our channel, please consider becoming a member, and can't wait to see you at the next tutorial where we're going to tackle the rocker arm assembly. So until then, thanks again for learning with the Learn It channel. Hope to see you at the next one.